Okay, this lesson is going to cover parallel lines and transversals. So specifically, we are talking about now if parallel lines are cut by a transversal. Previously, we were just talking about any old lines being cut by a transversal, but it turns out that if the lines are parallel, then something special happens with those angles. And the way that that will be abbreviated, you may see this in the book, is they draw the little parallel lines and a line going through it. So if you see that symbol, that just means if parallel lines are cut by a transversal. So the corresponding angles postulate is the first one. This is the only one that's a postulate. The other ones are going to be theorems. So the corresponding angles postulate says that if parallel lines are cut by a transversal, then corresponding angles are congruent. So in my figure here, if I wanted to find the measure of angle 7, the corresponding angle with it is 125. So I know the measure of angle 7 would have to equal 125 degrees. The alternate interior angle theorem says that if parallel lines are cut by a transversal, then alternate interior angles are congruent. So in my figure here, angle 4 and angle 5 are alternate interior angles, and so I know that angle 4 is congruent to angle 5 by the alternate interior angle theorem. The alternate exterior angle theorem is almost the same. It says if parallel lines are cut by a transversal, then alternate exterior angles are congruent. So in my figure, 1 and 8 here are alternate exterior angles, and so by the alternate exterior angle theorem, I know that they are congruent to each other. The fourth theorem is the consecutive interior angle theorem. Okay, this one is special or different. Let's see here, where's my pen? There we go. This one's different, it's special. So do something to remember that that one is different than the others, because if I have alternate interior angles, well, first of all, I have to have parallel lines cut by a transversal. So if parallel lines are cut by a transversal, then consecutive interior angles are supplementary. And if you look at the figure, you can see angle 3 is an acute angle, angle 5 is an obtuse angle. It's pretty obvious if you just stop and think about it when you look at the picture that they are not congruent to each other. They're clearly different sizes from each other. So if you have alternate interior consecutive interior angles, they're going to be supplementary. So what I would say about these is that the measure of angle 3 plus the measure of angle 5 would have to equal 180. And I can say that because of the consecutive interior angle theorem. So that's the one that's different. All the other ones are congruent, but if they're consecutive interior, then they are different, and that's the one that's supplementary. Okay, so we've got an example here. If I want to find the value of x, so first of all, I look here and I've got 113 and I've got 3x minus 4. Well, R and S are parallel to each other. I know that because they've marked them with the little arrows there. And this other line is my transversal, and they are alternate exterior angles. So by the alternate exterior angle theorem, I know that 113 is going to have to equal 3x minus 4 because those angles are congruent to each other. So then you add 4 to both sides. You get 117 is equal to 3x. And then if you divide both sides by 3, you would get that x is equal to 39. Okay. Example 2, we have 3x minus 7 and x plus 5 for the angles, but those are they aren't corresponding, they aren't alternate interior, they aren't alternate exterior. So I'm going to go ahead and label this angle down here as angle 1. So by the vertical angle theorem, I know that the measure of that angle 1 is going to also be 3x minus 7 because vertical angles are congruent. So by the vertical angle congruence theorem, I know the measure of angle 1 is equal to 3x minus 7. Now I'm looking at angle 1 and the angle that has a measure of x plus 5. Those are consecutive interior angles. And so by the consecutive interior angle theorem, I know that they are supplementary. And so that means that the measure of angle 1 plus x plus 5 was going to have to equal 180. Well, we already said the measure of angle 1 was 3x minus 7, so I'm going to substitute that in. I'm going to put 3x minus 7 plus x plus 5 equals 180, and then I'm going to solve for x. So combining like terms, I have 3x and x, that's 4x. Negative 7 plus 5 is negative 2. That equals 180. Adding 2 to both sides, I get 4x is equal to 182. And then dividing by 4, I find that x is 45.5. And so that would be your final answer for example 2. Okay, so I'm going to have a couple of problems for you to try on your own. So first I need to have a couple of parallel lines here and a transversal. Oops, that's not very parallel, is it? Okay, so if this is 72 degrees and we have 7x plus 24, and I want you to find the value of x. So go ahead and pause the video and solve this on your own. Okay, so vertical angles, I know that this angle down here also has to be 72, and now I have consecutive interior angles, so they have to be supplementary. So 72 plus 7x plus 24 equals 180. If you combine like terms, 7x plus 96 is equal to 180, and then subtracting 96, you get that 7x is equal to 84, and dividing by 7, you get x equal to 12. All right, and I've got one more for you to try on your own on your whiteboards. All right, so for this one, I've got 151 degrees for that angle, and this one is 2x plus 1. Find the value of x. pause the video now. Okay, so because they are alternate exterior angles, their measures should be equal. So 2x plus 1 equals 151. And then you subtract 1, 2x is equal to 150. And dividing by 2, x is equal to 75. And that concludes this video. Thank you.